Sixth grade, lesson 13.7 is describing distributions, describing the data, really, and we'll focus in a little bit on distribution. Let's do a quick little review of describing data. One way to describe the data we might have collected by a question is to describe its center, and we do that with the mean or the median, sometimes the mode. Usually mean is pretty accurate unless there's a major outlier on there. The median might give a better picture of what the center of the data is. We can describe it with the spread of the data using the range, the highest number in the data set, subtracting the lowest number from it, or the interquartile range, which is that upper quartile and then having the lower quartile subtracted from it. Range is good if the data is pretty evenly distributed. That gives you a good idea of the spread. But if there's some outlier in either direction, then the interquartile range probably gives a better explanation of the variability or the spread of the data. We describe the data by the shape on the graph. By using a dot plot or a histogram, we can talk about the shape of it. Is it symmetrical? Remember, that's like if you drew a line down the center of it, and you folded the page down the center, would they match up? Like looking in a mirror, symmetrical. Or is it more leaning to one side or the other? So, and within shape, it also, you can kind of look at distribution, kind of goes in with that. So I'm going to put distribution under that kind of umbrella there. And that's what they're kind of talking about, teaching about today. So to clarify distribution, could you describe whether there's any clusters, like groupings of them grouped together? Are there any peaks, like a highest point? Are there any gaps in the data? And is it symmetrical? Does it have symmetry? So something that would be symmetrical would be something like, if that was my center, and it almost looks like if I drew a line down the center, it looks the same. Mountain peak there. Something that would not have symmetry would be like this. Because it's leaning more one direction. So these would be the way we describe the distribution of the information. So the book's going to take us through one example that we would do in our classroom. We're not in classrooms right now, so I had to use randomizer.org to get my information. But maybe you have several people you could ask and get the information from, or if you're looking at this a couple years from now and you're not doing school out of class because of COVID and you're back in class, then you'd have classmates you can ask. So you could use your data in this circumstance instead, but I'm going to go ahead and give you my data for this one, walk you through how you describe center, spread, shape, and in terms of shape also the distribution of the data, so that you can see what all that means. Okay, so they say ask at least 20 students in your school how many pets they have. And of course, if you were going to do that, you'd want to be very random about it, fair about it. So maybe you put all the names of the kids in your school in a hat and you draw 20 names, and those are the people you ask, because it's important to be random so that you get more accurate data. Record your results in a frequency table like the one shown. Number of pets 0, 1, 2, 3, and 4. How often did people answer one of these 4? And what statistical question could you use your data to answer? So we're really finding out how many pets the students in our school have. So that would be our question. We're trying to find out how many pets, on average, do my classmates or schoolmates have? That's our question we're trying to find out. So since I'm not in a classroom currently, or in a school in person currently, I went ahead and went online and used randomizer.org to get my 20 student answers, and I wanted it to be random. And so here's how my data came about. So there was the responses to my data. 2 had 0 pets, 6 people had 1 pet, 3 people had 2 pets. 3 people had 2 pets, 5 people had 3 pets, and 4 people had 4 pets. So we can graph our data to see the center, spread, and overall shape of the data. And they say make a dot plot or a histogram of your data. So I'm going to go ahead and make a dot plot. The reason I'm choosing the dot plot is that helps me see any peaks specific to that. Remember, a histogram is an interval of numbers, like from 0 to 3 and then from 4 to 5. And I'm only dealing with numbers 0 through 4. So the type of graph I'm going to use is a dot plot. Well, I'm not dealing with that many numbers. I don't need specific intervals. And how will you label your graph? I only need data from numbers 0 to 4, 0 to 4 pets. So I'll draw my line, put a 0, 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to go ahead and put all of these pieces of information as dots here. I'll do that now. All right, and there is my dot plot, all of this data put into dots. Okay, we would turn the page and look at the questions they ask us. Okay, here's that second page. So they want us to think about the overall distribution of the data. These are those questions I mentioned earlier. Are there clusters? Are there peaks? Are there gaps in the data? Does the graph have symmetry? So I'm going to start with the clusters. Clusters would be groupings that are separate from others, and it's all kind of one big cluster. So it's all one cluster, I guess, is how I will describe my piece of data. Now, if you got different samples, you'll be describing it differently. It depends on what data you were picked up from your 20 classmates. Are there peaks in the data? Yeah, it looks like there's 2 peaks, one main peak, but there's at 1 and 3, there's some peaks. Peaks at 1 and 3. Are there gaps in the data? No, not really. No gaps. And does the graph have symmetry? Am I seeing something that kind of matches this way? It kind of goes up here and then it goes over. I would say, I don't know, not so much symmetry. Maybe if this was down to 2 and it kind of looked more so like that, I would say it was more symmetrical. I'll just say not very symmetrical. I mean, kind of, but not. Okay. So that's how I'm describing the distribution. I'm looking for any clusters, looking for any peaks. Are there any gaps? Does the graph have symmetry? And so I've answered the distribution. Let's compare the centers and the spread. So centers would be mean, median, mode, and the spread is going to be interquartile range and range of the data. So to find the mean, I need to add all of these pieces of information up, and when I add those together, I end up with 43 for my data. And there were 20 people I asked. I would need to do that division. 20 goes into 43 only twice. It gives me 40 with 3 left over. Decimal, 0. 20 fits into 30 only once. 1 times 20 is 20. I get 10 left over. And 20 goes into 100 5 times. So my mean is 2.15. That's the mean. Or 2.2 if I want to round it to the 10th place. My median, when the information is ordered least to greatest, and the dot plot did that for me, will be the center or the middle of all of it. So I'm just going to do the smallest, cross them off as I go. Smallest, biggest, 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 and I end up with 2 as my median. 2 and a 2. The number in between 2 and 2 is just 2. The mode is the most repeated, and the most repeated one was the 1. And so for the purposes of the center on this, mode isn't a good way to do that. It didn't give me the center very accurately. Mean and median, $2.15 is almost the same as just $2. They ended up being super duper duper close. So for this data set, I mean, I did not really have a ridiculous outlier, right? For this data set, either mean or median was a good measure of my center. Which measure of center do you think best describes your data? Either mean or median. They came out basically the same. They want me to draw a box plot of my data and use it to find the interquartile range and the range to find my spread. So this helped me identify the center of my data, and now we're going to really look a little closely at the spread of the data. And of course, we already know that our median was 2 because we found that in the last question. So now I need to find, if my median was 2, I need to find the median of the upper set, and I would cross off the upper set until I got to my median, and that ends up being 3. So that's my upper quartile. Then my lower quartile is my median of my lower set, this part. And when I crossed off until I got to the middle, that lower quartile, the median of the lower set, ends up being 1. And then, of course, my whiskers, 0 is the lowest value, 4 is the highest value. So my interquartile range, that is this part. I take the upper quartile 3, subtract from it the lower quartile 1. 3 minus 1 is 2. That's how far it spreads from here to there, is 2 units. And then how far from here to here for the range, take the largest value 4, subtract from it the lowest value 0, and I'm going to get 4. Does the interquartile range or the range best describe my data? The answer will depend on what your data looks like. For me, I'm going to say that the range does better than the interquartile range, because the interquartile range makes me think the majority of my data is bunched up together in here. But when we looked over here, it was evenly spread out for the most part, other than at 0. But it's evenly spread out. Even the 4 has a good bunch of them too. So for my data set, the range gives me a better idea of what the spread is because it's pretty evenly spread out. So that's how I would answer that. And what is the answer to the statistical question you wrote on the previous page? That was, how many pets do my classmates have? Well, my classmates tend to have, on average, about 2 pets, is how I would answer that. So this lesson was just giving you a little more question on, or a little more practice on all the stuff we've been learning in this chapter, and using it a little more to be able to describe data. There's lots of ways to describe data. You could use the center, the mean, median, mode, spread, range, or interquartile range, depends on the scenario. The shape of your graph, the dot plot or the histogram, and within that shape, what was the distribution like? Within that graph, what was the distribution like? Were there any clusters, any peaks, any gaps? Was it symmetrical? So that's everything they're just trying to kind of get you to practice with. I think you'll do just fine here.